Hello, this is Frederick Wakliaka. I'm back. I'm back with a topic many of you would um, I've talked about introducing this topic, and it is sovereign intelligence, the executive blueprint for auditing corporate AI and eliminating shadow data leaks. So, without much further ado, and without wasting any more time, let's get into the loop, into the thick of things. Sovereign intelligence, the executive blueprint for auditing corporate AI and eliminating shadow data leaks. Consider a scenario frequently encountered in our current operational landscape. A high stakes client proposal is due within a compressed time frame. An employee seeking to optimize throughput utilizes an unsanctioned AI chatbot on an unmanaged endpoint. They input 6 months of proprietary pricing structures, sensitive client communications, and unique internal methodologies to expedite the drafting process. The document is finalized and the deadline is met. On the surface, a victory for productivity. So, like we are seeing in the diagram here, we have 77% of companies lacking formal AI governance. Shadow AI has become a silent data exfiltration event. This framework moves organizations from unauthorized leakage to sovereign intelligence through visibility and architectural hardening. So this is you can see the unauthorized leakages here. This is the shadow AI. Then we have network visibility and packet inspection. Capture, um, capture outbound data to identify hidden secondary API calls to third-party services. Then this is an attempt of phase one to map the invisible data flow. Identify visibility with SSO, enforce single sign-on to ensure every AI interaction leaves an, in it leaves a trail so you can audit. Then you have a comprehensive tool inventory, categorize entry, active, by data visibility. So as you can see for this diagram, this is showing you the phases: network visibility and packet inspection, identity visibility via SSO, comprehensive tool inventory. Then we talk about the 10-minute exfiltration point. The technical reality is far more concerning. Embedded deep within the commercial terms of that service is a clause authorizing the retention of user inputs for model optimization. Your organization's proprietary proprietary uh, intelligence has now been ingested into a third-party training pipeline. So this is not merely a theoretical risk; it is the definitive operational reality of 2026. Without a formal framework, your data is currently being exfiltrated under the guise of efficiency. So we have only 23 of companies have formal AI rules. In the other 77%, shadow AI is a live ongoing data exfiltration event dressed up as productivity. You have an employee has a proposal due in 2 hours. They paste 6 months of internal pricing data, client history, and proprietary workflows into a free AI chatbot on a personal browser. Two, pushed proposal generated, deadline met, zero alarms triggered. Now three, per page 14 of the tool's TOS, all proprietary logic enters a commercial training pipeline. The data is permanently exfiltrated. Mapping the invisible data flow. We have a case study of mapping the invisible data flow. Case study, the telemetry trap. Here we have the user device, corporate perimeter, Helvetica now display, route A primary connection, legitimate mobile server, route B secondary APIs, NLP analytics, telemetry servers, ad targeting algorithms. This is a case study. An employee uses an approved AI writing assistant to draft a client engagement strategy. The tool silently pings a third-party NLP analytics service to improve ad targeting. The proprietary linguistic fingerprint is now stored in an external advertising intelligence database. So when we talk of shadow AI, we already talked about the technical architecture of state of AI governance in 2026. Metric and statistic and strategic status organizations with formal AI governance, according to statistics, only 23% have regulated uh, their AI. That is, have instituted safeguards, sensitized their staff about the dangers of using third-party AI, which is not authorized by the company or with existing within company official policy. Organizations impacted by shadow AI, 77%, that is a big, sizable majority, have unmitigated exfiltration risk. That is, when we talk about unmitigated exfiltration risk, they are they are they are they are the levels by which the data can be seized and used by unauthorized external actors is very high. It's unmitigated means there is no mitigation. It is not even consciously, or it is not. It's not. It's it is not even authorized, or they have no knowledge about what it being exfiltrated. So defining core objectives: shadow AI, the proliferation of AI assets and services operating outside the visibility and control of information technology and security departments. It represents a pervasive blind spot in the corporate perimeter. Sovereign intelligence strategy. When we talk of a sovereign intelligence strategy, this is a robust architectural framework designed to capture the performance gains of large language models while maintaining absolute custody over the data, logic, and intellectual property that constitute the organization's competitive advantage. So in our diagram here, we are talking. We are this is a layer. We are, this is a layered visibility of an advanced audit framework. When we are seeking to have a sovereign intelligence strategy, this is part of the robust architectural framework, which were which is designed to capture the performance gains of large language models while maintaining absolute custody over the data, logic, and intellectual property that constitute the organization's competitive advantage. So, network visibility, deploy packet inspections at the egress layer, categorize all outbound data flows to uncover hidden API endpoints, identity visibility, enforce strict SSO and MFA, prohibit personal email access, ensure every AI interaction is tied to a corporate identity for logging and revocations. Sorry. Tool inventory. The tools you use, you have traffic analysis, browser extension audits, and employee surveys. One recent corporate audit discovered 47 distinct unauthorized AI tools operating simultaneously outside of IT governance. So, to manage an environment, one must first achieve total visibility. We cannot secure what we cannot see. Our audit framework is structured and tool identity. Inventory. This is not a passive review, it is a forensic exercise designed your perimeter. We must move beyond vendor approval and towards continuous technical verification. So when we talk of layer one, that is the network visibility egress mapping. Objective of this network visibility: identify all external endpoints receiving data from internal assets. Mechanism: SSL TLS inspection, break and inspect. Since virtually all AI traffic is encrypted via HTTPS, standard packet headers are insufficient. Architects Architects must deploy SSL, inspect, and re-encrypt traffic. Without this, secondary API calls remain invisible. Traffic categorization: distinguish between primary connections, the user-facing AI interface, and secondary API calls, background telemetry, analytics, and third-party model improvement hooks. So that is layer one. That is the network visibility layer, where there is and then we go to layer two, identify and identity and inventory controls. SSOMF mandate that on the layer two, secure all interactions via a corporate single sign-on SSO, like we in the diagram here, identity visibility. If a vendor does not support SAML, ring and on pass system LP, to the third NLP analytics. So as employees, unique these fingerprints were ingested into a broader advertising intelligence database to refine targeting algorithms, effectively leaking the organization's strategic intent to the public domain. Forensic assessment, the mechanics of output stress testing. Um, Visibility into the present is vital, but we must also address the historical black box. Um, for many organizations, the question isn't if data has been leaked, but to what extent it has already influenced public models. We utilize a technique known as output stress testing to assess the residual risk of past exfiltration events. We have a stress testing pipeline, structured prompting, crafting high entropy prompts designed to trigger memorized weights within public LLMs, pattern identification, scanning model outputs for exact matches of internal terminology, unique project code names or proprietary process descriptions found only in internal repositories, weight influence analysis. While the direct weights of commercial models are inaccessible, mirrored outputs provide a directional signal that corporate intellectual property has been used for training. So we have the diagnostic question, deconstructing the black box forensic assessment. Has damage already occurred in the last 12 to 24 months? The probability high. The technique outputs stress testing, crafting specific prompts to public models designed to surface memorized internal language or proprietary client terminology. So this method gives you directional signals for deeper investigation. What it doesn't give you is absolute proof of ingestion or a definitive clean status. The hard truth, you cannot legally or technically delete a specific pattern from a compiled neural network weights prevention architecture is worth 10 times the investment of incident response. So the critical limitations we have with the stress testing pipeline is the probabilistic variation. AI outputs are non-deterministic. An unmatched provides no guarantee of data safety. The erasure fallacy. Technical reality supersedes legal protections. While right to erasure exists in policy, you cannot technically delete a learned pattern from a neural network's weights once training is complete. Prevention is the only absolute remedy. Then we have the hardening level, the data layer gateway proxy architecture. Rigidly blocking AI is a failed strategy. It merely incentivizes employees to utilize unmanaged endpoints and mobile networks to bypass controls. Instead, we implement a hardening level one approach, the AI firewall. By deploying a local gateway proxy, we maintain productivity while enforcing strict data governance. So here, a sovereign intelligence strategy requires distinct controls at the hardware, gateway, and workflow levels to completely eliminate data exfiltration. So, by providing controls at the hardware, gateway, and workflow levels, you try to control and eliminate data exfiltration. Application layer, you have zero knowledge prompts. Data layer, local gateway proxy. Infrastructure layer, local private cloud models. And then you have your internal user network at the very bottom. The proxy evaluates outbound prompts in real time. If the data category, e.g., PH1, P11, PH1, or intellectual property exceeds the risk threshold for that specific endpoint, the transmission is blocked or sanitized. De-identification. The system automatically strips corporate fingerprints like you are, replacing them with a richer external provider. Control over the data reaches the external provider. comprehensive interaction logging. Unlike consumer grade interfaces, the proxy ensures every prompt editing and threat hunting. Sensitivity work that the picture of our business logic. We treat the LLM remote processor, not a trusted collaborator. Technical architecture sidebar. Step one, minimalization and we have a data layer and application layer controls. The gateway proxy data layer. It inspects the prompt against classification policy. Strips and replaces proprietary corporate fingerprints with neutral equivalents, logs the sanitized interaction before sending it to the external API. Zero knowledge prompts application layer. The external AI receives only the minimum necessary context components to perform a task. The model never sees the full picture. The user recontextualizes the output internally. So in this, for high sensitivity workflows, we move beyond simple prototyping to a zero knowledge design discipline. This ensures that the external model is never granted the full picture of our business logic. We treat the LLM as a remote processor, not a trusted collaborator. As we saw in the technical diagram, the internal application strips all sensitive context from a task. For example, a pricing optimization task is stripped off the client name, project SKU and region. Step 2, external processing. The external LLM receives only the mathematical or linguistic logic required to perform the transformation. Step 3, internal rehydration. Once the output is returned to the secure corporate environment, the system reintegrates the sensitive identifiers. The knowledge remains internal, only the processing is. So mandatory use cases for that would be the proprietary pricing algorithms and margin logic, unreleased product development and R&D, M&A strategy, and sensitive client relationship management. Okay, now we go to I'm getting to the right slide. Excuse me a moment. The ultimate stage of sovereignty is moving the model to the data rather than the data to the model. The performance gap for standard business tasks, summarization, classification, and drafting has closed. For many medium enterprises, local or private cloud deployment is now the most effective and secure path forward. Technical architecture. For example, we have in this where we use the local or private cloud deployment, We have a feature is local deployment on premises, private cloud, single tenant. Data sovereignty is strictly contractual, absolute air gapped potential high. Hardware requirements, modest enterprise GPUs, NPU clusters managed by vetted CSPs, ideal use case tier 1, proprietary intelligence and R&D, tier 2, operational data and scalable apps, cost profile, capex heavy fit standard IT budget, it's scalable and intermediate. So when we talk about tier 1, the sovereign intelligence tiering system, the pricing models unreleased IP competitive strategy. The enforced control is air gapped to local private models, only no exceptions. Because we are on a private cloud. Tier 2 medium risk, process documents, non-confidential, client communication, proxy gateway stripping identifiers, and sanctioned enterprise tools. Tier 3 low risk, general research, basic drafting, approved external tools accessed strictly via corporate SSO. The continuous sovereignty cycle. Governance fails when it creates excessive friction. To eliminate the root cause of shadow AI, we implement a three-tier data access model. This allows us to apply the most stringent controls only when they are truly required, providing a fast path for low-risk work. In Tier 1, the highest value proprietary intelligence examples. You have local air-gapped environments only, pricing models, M&A documents, source code, trade secrets. Those are in tier 1, which is the highest value proprietary intelligence, where you have trade secrets, pricing models, M&A documents, source code. The constraint processed via locally air-gapped environments only. External LLM access is technically bad. It's technically bad. Tier 2, sensitive operational data examples, internal project updates, non-confidential client communications, constraint. They are processed via proxy gateway with mandatory de-identification and logging. Tier 3, low sensitivity general work examples, public research, which is low sensitivity, general drafting, grammatical refinement, constraint, sanctioned external tools with standard corporate identity SSO controls. So immediate audit initiated. Here we have a trigger 1, the continuous sovereignty cycle, automated generation of inventory data reports and egress delta reports and egress traffic analysis. Trigger 2, vendor update triggered mandatory review initiated when a vendor pushes minor version releases, checking for altered data handling terms or new third-party integration. Immediate audit initiated the moment a new unauthorized AI tool is detected on the network. Technical controls. In conclusion, sustaining the sovereign strategy. Technical controls are a necessity, but sustainability depends on the human layer. Most exfiltration events are not the usual result of malice. Most exfiltration events are not the result of malice, but of uninformed attempts to achieve results. Our goal is to replace shadow behavior with sovereign behavior. This requires a commitment to a recurring automated audit cycle. The strategic audit cycle, quarterly reviews, comprehensive assessment of tool inventory, egress traffic deltas, and policy effectiveness. Event-triggered audits initiated immediately upon a vendor's minor version release, or change in data handling terms. Incident triggered audits triggered the moment a new unauthorized endpoint is detected via egress monitoring. So my call to action is data is leaving your network as we speak. If you want to seize control, your first priority must be egress visibility. Do not wait for a policy update. Run a packet inspection analysis this week. Understand exactly what is leaving your network before you attempt to govern how it is used. In the age of AI, precision, not just restriction, is the key to intelligence sovereignty. So, the human layer solving the root cause, the failure of blocking. Blocking AI accelerates shadow behavior. Employees act rationally to meet productivity demands. If sanctioned paths are bureaucratic, they will bypass them. The enablement solution provide fast, capable, approved tools for everyday tasks. Tier 3. Training directive stop training on abstract privacy concepts. Train employees on the concrete, permanent commercial risks of feeding pricing logic into external training pipelines. Make the invisible risk visible. The blueprint summary is this: map egress traffic, enforce identity SSO MFA, deploy gateway proxies, enforce zero knowledge prompts, tier data access. The goal is precision. Give your people powerful AI within a framework that ensures your strategic intelligence remains exclusively yours. Where to start this week? Run an egress visibility analysis, run packet inspection on outbound AI traffic immediately. Knowing exactly what is silently leaving your network today reveals your actual risk profile infinitely better than any vendor compliance review. Framework developed by Frederick Cybersecurity. Drop a question to go deeper on configuring this framework for your specific tech stack. Oh, thank you very much for bearing with me. I hope you've enjoyed this brief brief class. I'll see you again. Thank you.